Here we got a problem that I gave yesterday to my students, and we had a really good conversation at the end of what's the best route to go about a problem like this. We've got 6 different equations. They all have J and B, which is going to be representing Jada's age and her brother's age. And we're given some information about Jada and her brother in comparison to their age. So Jada is 3 years older than twice her brother's age. One way I would attack a problem like this is I would just come up with 2 values that would work. Okay, so we know that Jada is 3 years older than twice whatever her brother is. So give her brother an age, just pick a number. So let's say her brother's 6 years old. So brother is 6. What would that make Jada based off of what we know? We know Jada is 3 years older than twice her brother's age. So what's twice her brother's age? If her brother's 6, that would be 12. And then she's 3 years older than 12, so that would make her, Jada, 15 years old. You take the 6, double it to make 12, add 3 more to it, Jada must be 15. So now that we have these 2 pieces of information, we can plug a 15 in for J, a 6 in for B, then we can find which of these 6 equations would work. Those would be the ones that would be representing this relationship between Jada and her brother. Okay, so there's one up here that's clearly obvious. I would have probably picked it before I even picked these numbers. It's pretty clear to see that if you take Jada's brother's age, double it, add 3, that's going to give you Jada's age. So we're going to put a check next to this one because I like A. A is going to work. We can prove it by putting a 6 in. 6 times 2 makes 12, plus 3 more gives me 15, which is what we would have in place of J. Now, if we go through each of these other ones, there's one other up here that is going to work, and it's not as easy to tell which one that is. So getting these 2 numbers makes this process much quicker, much simpler to find the one that's going to be a correct relationship. So let's put a 15 in for J here, a 6 in for B there. 6 divided by 2 gives me 3. 3 minus 3 is 0, not 15, so we're going to put an X next to B. Let's put a 6 in for B, and then a 15 in for J. 15 minus 3, so 15 minus 3 would give you 12. 12 divided by 2 would give you 6. Hey, that works, so we're going to put a check there. I'm going to tell you right now, A and C are both correct. Let's double check and see if D, E, and F also work. So let's go and check D, E, and F real quick. We're going to put a 15 in place of J, a 6 in place of B. So 6 plus 3 would be the first operation to be done because it's in parentheses. 6 plus 3 makes 9. 9 times 2 makes 18. Remember, we wanted that to be a 15, so D does not work. B is going to get a 6. J is going to get a 15. 15 times 2 is 30, plus 3 makes 33. That one doesn't work. And then last but not least, 6 in place of B, 15 in place of J. 15 divided by 2 is 7.5. We already can tell that that one's not going to work. So our final answer here would be A and C. These are the 2 equations that correctly represent the scenario between Jada and her brother. This one stood out right away. This one, you don't see it quite as easy. Let's find out why C also works. Okay, if I took C and I can get J isolated like it is up here, let's see what happens. So we're going to get rid of the 2. It's divided by 2, so we're going to get rid of that by multiplying by 2, inverse operation. Multiply the other side by 2. It leaves you with 2B equals J minus 3. Inverse operation of minus 3 plus 3 cancels, plus 3. Now I've got 2B plus 3 equals J, and what do you know? This equation is exactly the same as this one right here. They're the same 2 equations, just rearranged when you were looking at C. Hopefully this makes sense. Study hard and good luck on your upcoming test.